Hello everyone. In last video, we saw a suboptimal approach, that is sorting with binary search, which had a time complexity of on plus on log n. In this video, we will look at another suboptimal approach, sorting with two pointer. This will have the same time complexity as sorting with binary search. In next video, we will look at the optimal approach. Let's talk about coming to the two pointer solution to solve some problem. The two-pointer technique is particularly effective when working with sorted arrays due to its ability to efficiently solve problems by leveraging the sorted order. One of the use cases of this technique is searching for a pair of elements in an array that meet a criteria. This use case is perfectly fit for two-sum problem. It involves maintaining two pointers typically starting at opposite ends of the array and moving them towards each other based on specific conditions. We will look at how this works for solving two-sum problem by looking at this test case, where nums is 7, 11, 2, 15 and target is 18. The expected output should be 0, 1 because 7 plus 11 is equal to 18. First step will be to sort the nums array into nums with indices array to keep track of number value and its indices. This step is same as that we did in our previous video for sorting with binary search solution. We keep track of indices because we have to return the indices of the chosen elements adding to the target. We will begin our search by initializing left pointer and right pointer at the two ends of nums with indices array. Left pointer will keep track of small element and right pointer will keep track of big element. We check if nums of left plus nums of right is equal to the target. No, it's not. Because 17 is less than 18, so we want to increase the value of small element from 2 to 3 to be equal to the target. So we increment the left pointer in hope to find 3 as the next element. We check again if nums of left plus nums of right is equal to the target. No, it's not. Now, instead of going near to the target, we moved away from the target. This is because the previous sum was 17, which was closer to 18, and 22, which is the current sum, is less closer to 18 than 17. So to come closer to the target, we will have to make our big element value smaller, and we do this by decrementing the right pointer. Now we check again if nums of left plus nums of right is equal to the target. Yes, it is. So we return 0, 1. Now let's code the solution up. We will create nums with indices array. We will do this by iterating through each and every element of nums array and extracting its number value and its index. Next, we will sort the nums with indices array. We will initialize our left pointer and right pointer. Left will be initialized to 0 and right will be initialized to length of nums with indices minus 1. We will begin our search by while loop. The condition would be left less than right. We will extract left number value and the left index by doing nums with indices of left. Similarly, we will extract right number value and right index by doing nums with indices of right. We will calculate the current sum, which will be equal to left of num plus right num. Now we will check if current sum is equal to the target. If they are equal, then we have found the two pair whose sum are equal to the target and will return their indices, which would be left index and the right index. Next we will check if current sum is less than target then we want to increase the value of our small element so that the sum is equal to the target. We do this by incrementing the left pointer. Else, we'll decrement our right pointer. Let's submit the solution. It got accepted. Let's talk about the time complexity and space complexity of our code. Line number 3, we create nums with indices array which takes O of n time because we are iterating through each and every element of nums array. It takes O of n space to store number value and its index. Next, at line 4, we are sorting the nums with indices array. This takes O of n log n time complexity and O of n space complexity. Line 8 to 18 takes O of n time because we, in worst case, traverse through all the elements of nums with indices array. So the total time complexity is O of n plus O of n log n. The total space complexity is O of n. In next video, we will look at optimal approach to solve two-sum problem. Thank you for watching this video and stay tuned.